Good morning, class. Yesterday we have started our chapter number 2, polynomials, and we have seen the basics of the polynomial, like definition of the polynomial, what is a polynomial, then types of polynomial, degree of polynomial, zeros of the polynomial, and last we have seen graphical representation of the polynomials, of linear polynomial, of quadratic and cubic. There we have drawn one relationship, or you can say one conclusion. Yesterday we have drawn that linear polynomial will have 1 0, quadratic polynomial will have at the most 2 zeros, and a cubic polynomial will have at the most 3 zeros. So today's topic is relationship between the zeros and the coefficients of a polynomial. What we have to find? We have to show the relationship between the zeros of the polynomial and the coefficients of the polynomial, right? So again, what were the zeros of the polynomial? If we are given with any px, right, polynomial px, and we are able to find a value a which makes this polynomial equals to 0, then this a is known as 0 of the polynomial px, right? Okay, and what are coefficients? Let me take any polynomial like 7x square plus 9, right? The number which is just written before, the constant which is written before or in the multiplication of the variable in each term is known as coefficient of the polynomial, like this, and this term without variable will be considered as constant term, just constant. Okay, these constants, because they are written along with the variable, they are coefficients, and without the variable it is a constant term. Okay, now relationship. Let's try to make or create a relation between these two, right? Let me first take a linear polynomial. Linear polynomial. What is the relation and what was the linear polynomial? First of all, let me take the general form of it, ax plus b, where a is not equals to 0. Okay, you have to note down this thing, a is not equals to 0, because if this a is 0, then this term will become 0, and here px will be equals to b only, right? Px is equals to some constant, right? So it will not be a linear polynomial anymore. For linear we want x term with degree 1, no, right? If it will be px is equals to b, then we can't say this is a linear polynomial. Okay, so we are taking a linear polynomial, and what we have to find its zeros first. What are the zeros? To find the zeros, just keep it equals to 0 and get the value of x. X value is minus b upon a. Now can you see the relation between this 0 and these coefficients? Yes. What can we write? This b is the constant here, constant term, and this a is the coefficient of x, coefficient of x, right? Okay, so x is the 0 which is further equals to, what is the relation? Minus b, minus of constant and coefficient of x, right? So we can apply this on any general or example. Let me take px is equals to 2x plus 7, right? So what is the use of finding this relation, right? Here you can simply write what will be your x, what will be the 0 of the polynomial, minus constant upon coefficient of x. Minus constant term is 7 and coefficient of x is 2. Right? So this way you can find the 0 of the polynomial. Let me take one more example. Px is equals to 5x minus 3. To find the value of x, you use the relationship minus b upon a, minus constant upon coefficient of x. Here it give you, compare this with ax plus b with the general term. What is the value of a? Value of a is 5 and value of b is minus 3. Okay, just take care of this thing. B will be now minus 3. So minus of minus 3 upon 5, that will be equals to 3 upon 5. Okay, so this is the easy way to find the 0 of the polynomial, okay, with the use of this relationship. Alright, now this was about linear polynomial. Let me start the quadratic now. Note it down. Now the relationship between the zeros and the coefficient of a polynomial which is quadratic, right? Quadratic polynomial, let me write its general form now. It will be px is equals to this. Here we note that a should not be equals to 0. Why? Because if this term becomes 0, then it will be no more quadratic, it will be a linear polynomial, right? If this term is 0, then it will be equals to bx plus c, right? Which is linear. Alright. So, for quadratic, let me take alpha, 0 of the polynomial, any values of x which makes this polynomial 0. Now we are taking alpha and beta are the zeros of polynomial px. This I suppose alpha and beta. Okay, these are the notations or you can say symbols, right, for the zeros of the polynomial px. So what is the relation? Sum of zeros. Sum of zeros will be equal to minus b upon a. That means minus coefficient of x upon coefficient of x square. A is what? Coefficient of x square. B is what? Right? This relation you have to learn for the time. Okay. This we will prove by use of one examples along with this. Right? Okay. And what is second relation? Product of zeros alpha into beta will be equals to c upon a. C upon a, that is, c is what? Constant term upon coefficient of x square. Right? Okay. So these two relations for a quadratic polynomial you have to learn, and for these two relations we will check or verify the examples, right? So let me take 4 cubic, we will discuss along with the question. Okay. First, px I am taking as x square plus 7x plus 10, right? One polynomial px is equals to x square plus 7x plus 10, quadratic polynomial. Okay. Here, what will be the zeros of this polynomial? How to find the zeros of the polynomial? We have done in last standard splitting the middle term. You remember, I hope, right? So split the middle term of this polynomial into two numbers so that the multiplication comes to be 10x square. Okay. So what will be the factors? X square, 5x plus 2x plus 10, right? Here it will be x plus 5, right? 2 is common from these two, x plus 5. Now this bracket is common, x plus 5 and x plus 2. Okay, so this way you have split this quadratic. Now to find the zeros, keep every factor, each factor equals to 0 individually, right? So here we are getting x is equals to minus 5 and x is equals to minus 2. Okay. So notation for zeros of the polynomial was alpha and beta. Let me take one 0 as alpha and another 0 as beta. Okay. So alpha and beta we are getting minus 5 and minus 2. Now let's verify the relation. Okay. What was the relation? Sum of zeros alpha plus beta, it should be equals to minus b upon a, right? We will do the addition of these two and we will check the coefficients. Let me write the coefficient once. What are the coefficients? Compare this with ax square plus bx plus c and write the coefficient. Here a will be equals to 1. Compare this and this, right? Here it is 1 now. B's value will be equals to 7. Okay, compare 7x with bx. B is 7, right? Okay. Now c is what? C is 10. C's value is 10 here, right? So now we will add these, okay, and we will check the relation. Sum of zeros alpha plus beta is equals to minus 5 plus minus 2. That is equals to minus 5 minus 2 is equals to minus 7. Right? And what is your minus b upon a? Check minus b upon a. Minus b upon a is what? Minus 7 upon a. 1. So it is equals to minus 7 only. Okay? So here what we are getting? This and this same. Sum of zeros is equals to minus b upon a, hence verified. Okay, both the values are same. So it is equal. Sum of zeros, we can say zeros is equals to minus b upon a, hence verified. Another relation, we will write upwards. Check product of zeros. Product of zeros is what? Alpha into beta. Product of zeros. Alpha into beta is equals to what? Yes, these two multiply. Minus 5 into minus 2 will be equals to 10. And what is your C upon A? Check your C upon A. What is your C upon A? Is 10 upon 1. So these both values are same, right? So we can write product of zeros is equals to C upon A, hence verified. Alright? Okay. I hope that you understand this. Okay, if any query is there, please better keep on writing in the comment box so that I can get your feedback. Okay. Now we are discussing more equations, right? This is the first type of equation. This is type 1 equation. Okay, under the heading quadratic polynomial only, we are doing type 1 quadratic of first type, right? Now we will take another type of quadratic and we will verify the same relationship. Pause the video to note it down. So first polynomial I have taken was px is equals to x square plus 7x plus 10, right? This we have solved first type of quadratic, right? And we have seen the relation. Now second type of quadratic polynomial. P of u is equals to 4u square plus 8u. Okay? Forget it now and just concentrate over here. Why I'm taking different types? Because to discuss with you all types of polynomial, how to find their zeros, right? Here, 3 terms were there, so we have separated the middle term, okay? But in case we have only 2 terms, right? First and second term, compare with general form, ax square plus bx plus c, okay? What can we say? Here constant term is missing, right? Constant last term is missing. So in this case, what you need to do is take common from these two. 4u is common, right? What we are left? U plus 2, right? Okay. So how to find the zeros? Put two factors differently equals to 0. 4u equals to 0 and u plus 2 equals to 0. Here comes u equal to 0 upon 4. That is 0 only. Here comes u is equals to minus 2. So these are our alpha and beta, zeros of the polynomial. Write it by alpha and beta. Okay. Now we have to compare the relationship. Sum should be equals to minus b upon a and product should be equals to c upon a. Right. Okay. Just let me write the relation somewhere. Here only I will write. First, a's value 4, b's value is 8 and c's value is 0. Okay. Now sum of zeros, alpha plus beta. It means we had to add this to 0 plus minus 2. That equals to minus 2 only, right? And what is our b upon a minus b upon a? What is our minus b upon a? Minus 8 upon 4. That equals to minus 2, right? So what can we write from here? Sum of zeros is equals to minus b upon a, hence verified, right? Next is product of zeros. Product of zeros is what? Alpha into beta. Alpha into beta. Alpha is 0 and beta is minus 2. That will be 0 only. Okay. Now, what we have to see? C upon A. What is our C upon A? Check C upon A. 0 upon 4. Sorry for disturbance. So C upon A is what? 4. C is this. Take 1 minute. C is 0 and A is 4. That will be equals to 0 only. So we have verified product of zeros is equals to C upon A. Clear? So next type, first type 3 terms, second type first and second term, third type we will be having this type of polynomial. Just I will tell you, t square minus 15. It is from your NCERT only, right? In this type of polynomial, how to get its zeros? Here you need to write t square minus root 15 square. Okay, and now factorize this. Factor will be t minus root 15 and t plus under root 15. Okay, to get the zero of the polynomial, put this individually equals to 0. T is equals to 15 root and t is equals to minus root 15. This is your alpha and this is your beta. What are your A, B and C? A is 1, B is 0. B is 0 because middle term we don't have, right? C is minus 15. So you can verify the relation, I think, right? So pause the video to note it down, and one small concept after this we will learn, right? Now let's discuss the relationship between the zeros and the coefficients of a cubic polynomial, right? Cubic polynomial standard form is ax cube plus bx square plus cx plus d. Again, a should not be equals to 0, right? Need not to say, because if this a is 0, this will be a quadratic. This term will be 0, and here we will left with quadratic, not cubic, right? So what are the maximum number of zeros of a cubic polynomial? Yesterday we have discussed, if there is a cubic, it could have at the most 3 zeros. So let me take alpha, beta and gamma. Gamma are the zeros of px. This is your px here, right? So what is the relationship? Sum of zeros. These are the symbols only, alpha, beta and gamma. Sum of zeros. Sum of zeros will be equals to, alpha, beta, gamma will be equals to, yes, minus b upon a. It means coefficient of, minus coefficient of x square upon x cube, x square upon coefficient of x cube. Sum of 0, alpha plus beta plus gamma. Second relation, sum of two zeros taken together, that is alpha beta plus beta gamma plus gamma alpha. This is known as sum of product of two zeros taken together. Okay, product of two zeros taken together, that will be equals to c upon a, right? Means coefficient of x upon coefficient of x cube. Coefficient of x cube. Third relation, here we have three zeros and three relation, okay? Alpha into beta into gamma will be equals to minus d upon a, minus d upon a, that is constant term upon coefficient of x cube, right? Minus constant upon coefficient of x cube. These are the relationship, basically three relationship you have to remember, okay? Now we will verify this, right? One example is there in your NCERT. You are given with one polynomial and three zeros are already given, okay? Otherwise you know how to find its zero, okay? You have your exercise, I think 2.4 you are last done in 9th class, and it was the last question. First find the 0, 1 0 by hit and trial method, then do the long division method. Whatever quotient come, you split it and you will be getting rest of the two zeros, okay? You just ask me in the comment box if you need to revise that even, okay? I will be solving one question for you. Here we are given with zeros and polynomial both, right? Need not to worry to find the zeros, okay? Just we are checking, alpha is 3, beta is minus 1 and gamma is minus 1 upon 3, okay? So sum of zeros, and ABC you can write. A is what? A is 3, B is minus 5, C is minus 11 and D is minus 3. A, B, C and D, comparing with this standard form, right? So alpha plus beta plus gamma is equals to what? 3 minus 1 minus, okay, in between you can put this plus sign even, minus 1 upon 3, right? So what it is, 3 minus 1 minus 1 upon 3, that is equals to 2 minus 1 upon 3. This is 6 minus 1 upon 3, that is 5 upon 3. Clear? Now, alpha plus beta plus gamma, it should be equals to minus b upon a. So let's check what is our minus b upon a. Minus is in the formula, you can say b is what? Minus 5 and a is what? 3. So it will be equals to 5 upon 3. So these two values are same. It means sum of zeros, alpha plus beta plus gamma is equals to minus b upon a, hence verified. Okay. Second relation, I think you can do by your own. Alpha beta plus beta gamma plus gamma alpha, right? Do the multiplication, 3 into minus 1 plus minus 1 into minus 1 upon 3 plus minus 1 upon 3 into 3. Okay. Alpha, beta, product of first two, then last two, and then first and last. Right? What will you get? This will be equals to minus 3 plus 1 upon 3, and this will be minus 3 again. Minus 1. I'm sorry. Right? These two are cancelled out. Right? So what we are getting? Minus 4 plus 1 upon 3. LCM is 3 minus 12 plus 1. Minus 11 upon 3 we are getting. Right? So C upon A is what? C upon A. Just check. This is minus 11 upon 3 only. So here we have found the second relation. Alpha beta plus beta gamma plus gamma alpha is equals to C upon A. Right? Now the third and the last relation, let me write here, alpha into beta into gamma. What is this? Multiplication of 3, alpha, beta and gamma. 3 into minus 1 into minus 1 upon 3. It will be equals to 1 only, right? Yes. And what is your d upon a? Minus d upon a, that is minus 3 upon 3 is equals to minus 1. Right, here it is. Let me check. Minus of minus 3. Minus is in before d, and d is itself negative, right? So here it becomes positive. Okay. So these two are same. So we can write the product of zeros is equals to d upon minus d upon a. That is constant upon coefficient of x cube with the negative sign. So this is all about the relationship between the coefficients and the zeros of the polynomial. Hope you understand this, right? Try to do all the questions of exercise 2.2 starting with the examples, right? So question number 2 we will do tomorrow. One topic we have completed. So do try it yourself. All the very best.